What's up guys, Shawnthebro here, and in today's episode of the first-person shooter tutorial series, we are going to be going over floating damage numbers. So I can hit my opponent, and it will show the amount of damage that I've done. It will also clean up after a certain amount of time. And it will rotate toward us, or billboard toward us, so no matter where we are, we can see the damage amount. There's a lot more we can do with this to clean this up and make it more exciting to use. However, this is a very good intro on floating damage numbers. Now before we hop into the series, if you want to get caught up, you can go ahead and check out this playlist in the top right corner, which will show you every single episode we have for the first person shooter. And alternatively, if you don't care about that and you just care about the floating damage numbers, I recommend you watch this episode right here, which is where we go over collision between our projectiles and our enemies, which we're going to be building off of today to use our floating damage numbers. With that out of the way, we can go ahead and get started. This is a code and blueprint tutorial series. We've come far enough in the series that I think it is important that we start getting into more code. So we're going to create a new class today to handle our damage number, and it is going to be a C++ class. To add a new C++ class in Unreal Engine 4 or Unreal Engine 5, you can scroll down to your C++ classes section, and if you don't have this, you may have a little button here that allows you to pop out and hide this. We're going to want to find that and go to C++ classes, and I like to go into the folder that I have everything in and hit add new C++ class. You can select one of the common classes, but I pretty much always go to all classes and then search for the exact class that I want. Now in this case, I actually just want an actor. There is a text render actor, and this would really do what we want, but we may want to do more than just floating damage text. We may want to add other effects or even images to this effect. Like if we want to say we've done more damage or less damage at a certain time, we could add those in. And so I'm actually going to use a generic actor like this. I'm going to hit next, and I'm going to name it whatever it is that you want to call it. I called mine base floating text. And I already have it, so I can't use it here, but otherwise you would hit create class. I'm going to hit cancel. At this point, we can switch over to the code, the Visual Studio. And you should see in your folder that you created this class, the base floating text.cpp and base floating text.h. When adding the class, you may get pop-ups to reload the project or even to close it. And if you do, just accept them, reload the project. You should get these here eventually. I'm going to stop running mine because that's where you would be once you created this. And now I'm going to open up the base floating text.cpp and the base floating text.h. Let's start with the .h file because that is the header file. Now I have already added what I want to use for today's episode, but I'll show you what was here when I created this file. So you should have all of this logic here, this generated include here, all this behavior for creating the class, and the tick function here. So I have added one include line as well as two variables for this episode. There's also one thing I'm going to do live with you because I just find it a lot nicer looking. I hate that they do public, protected, then private again. There's nothing wrong with that at all, but it just kind of bugs me. So anything that I want public, I'm going to just move into the public section right here. So I'm going to get rid of this public, and I'm going to move all of this up here. Just because I think that cleans it up a little bit. So now before we do anything else, let's add this include. This include right here is going to allow us to add a text render component to our actor. And the text render component is what is going to display the text for our damage number. So it's very important that we have some widget or some object in the world that can display text for us. And that's going to be a text render component in our case. So all you have to do is hashtag include, and then we're going to use components / text render component.h. And that will get us access to the uTextRender component class here that we're going to need as a variable. So now let's make our two variables. I'm going to have one for the damage amount, so basically what amount do we want to display in the text, and then I'm going to have the text element itself. This is going to be the actual damage amount that we've done that we want to display to the user or to the owner of the damage, whoever did damage to the enemy that we want to display. And I've made it uProperty visible anywhere, blueprint read write, so we can access it and edit it in the blueprint. I've given it a category of text, and I've added this meta equals section so that we can add additional functionality. And specifically, we want to add the expose on spawn, because as soon as we create this floating damage number, I want to pass the damage into it. Our collision does happen to be in blueprint in this series for the time being, and so because of that, as soon as that collision occurs, we want to pass the damage into this object that we're creating, this actor. So if we do meta equals, parentheses, expose on spawn equals true, this means that this variable will be able to be filled out when spawning the actor. This will actually allow us to set the variable before begin play runs, which means that if we set the text in begin play to this amount, it will be the valid value. All that is for float damage amount. That's our variable. Now after that, I want to add our text render component. So I've made another variable. This one's uProperty of visible anywhere, blueprint read only, and we give it a category of text. Now this is a class uTextRenderComponentPointer, and I call it damage text. That's everything we need for our header file. We're going to go set this up in the .cpp. So when you come into the .cpp here, you'll have your comment, you'll have your initial include here for the header file, and then you'll have a constructor with the primary actor tick.be CanEverTick equals true in it. You'll then have the begin play calling super : begin play, and the tick calling super : tick. So I've added quite a few things to all three of the functions that already exist within this class. Starting out, I want to add an include for our Kismet/KismetMathLibrary.h. This is going to be important when we want to rotate the text toward the owner of the damage. That way, as we rotate around our enemy, it's still displaying correctly in our screen. We'll get into that in a few minutes, but go ahead and add this include before you forget. So Kismet/KismetMathLibrary.h. Now in the constructor, when this object is created, we want to set up our damage text render component and our default values for our variables. So our damage amount is going to be 0.0 by default. If it never gets assigned, fine, but by default it should be 0.0f. At this point, we can create our component and actually attach it to the root element of our actor. And so to do that, we want to use our damage text and set it equal to create default subobject. And this is going to basically make a component. If we were to have a blueprint class, you'd be able to edit it by clicking on it and seeing all the defaults. We don't have a blueprint class here, but really the same hierarchy occurs. When creating a default subobject, you have to pass in the type of the subobject that we're creating, and that is going to be our text render component right here. That is our variable type, uTextRenderComponent, and that is going to be the type that we're creating for this object. Then you have to give it an identifying name, and so I've just added text, and then in parentheses put damage text. You can actually put anything you want in there. That is just going to be how we recognize it in a blueprint. After we've created the subobject, we need to attach it to the root component. And to do that, we can use damage text, arrow, setup attachment. And you can actually attach it to any component, but we only have a root component, so we want to use get root component, which is already a default function in this class. Now at this point, the damage text is set up appropriately. I do want to assign a default value for the text because it's always good to do that. Otherwise, it'll be just completely blank, which isn't really useful to us. I mean, 0 is way better than blank. Damage text, arrow, set text. And I pass in my own string here. You could really do whatever you want, but I do ftext, : from string, and then in quotes I do 0. And to stay consistent, we should actually do 0.0. But that's just the default value. That's if this text is never updated for any reason. So if we spawned it but we didn't update it, it would display 0.0. Now let's go down to our begin play function. And we're going to want to actually update the damage text with our real value. That was the default value. Now we have our actual value that we want to use and display to the user. So we want to use damage text, arrow, set text, and then we're going to use our ftext : from string again, and then we're going to cast our float value, our damage amount, to a string. That way the string can be casted to text. To convert a float to a string, you can use fstring : sanitize float. And then inside the sanitize float, you have to pass in the variable that you want to use, and we're going to use our damage amount variable. So now basically the damage text component will display whatever is in our damage amount variable, and that's exactly what we want. Now, another thing we can do is set the lifespan of this object. That way it cleans itself up after a given amount of time. You can, by all means, start a timer, set an actual lifetime or number of frames that you want to keep it, and delete it after that time, or you can use the built-in Unreal behavior for this. Because this is just a display object and it doesn't have other logic on the back end that we're going to need for future use, I just set the lifespan. That way we can just let it clean itself up after a certain amount of time. And this is super simple. All actors can do this. You just use set lifespan and pass in a float value, which is the number of seconds. So set lifespan 2.0f means after 2 seconds, destroy this actor. Lastly, we have our tick function. And what I've added in here is the way in which we are going to rotate the text toward the player, or toward the owner of the damage. First thing we need to know is there an owner? Because if we spawn this and there's no owner, we won't have anyone to rotate toward, so we don't want to try and do this if there isn't an owner for any reason. So if get owner, damage text, arrow, set world rotation, and we're going to automatically be rotating toward the actor that dealt the damage, so it is always staring them in the face directly. It can't be rotated on its side so that you can't read the text that you did, none of that crazy stuff. We can use a function called findLookAtRotation, and that is in the Kismet Math library, and that is why we need this include up here. So Kismet Math library : findLookAtRotation, and we need a start and a target. The start is the rotation that we're starting with. The target is what we want this actor to look at. So the start is the get actor location. This is the actor that we're trying to make look at another actor. So we already have the location information. So we can just pass the get actor location in here. However, the actor we're trying to look at is the owner of this actor, because we're going to set the owner of this actor to the actor that dealt the damage. Basically, whatever actor caused this pop-up to occur, this floating text to occur, is going to be the owner. And we want to rotate this text toward the owner. So we're going to use get owner, arrow, get actor location. And notice these aren't rotations we're passing in, they're locations, because the actors know what direction they are oriented. And that is everything we need to do in the code. So the very last thing we need to do is launch our editor and go to where our collision is handled. The editor is open now, so we're going to go to where our collision is, and then it's going to be in our ammo. So I'm going to go to base ammo BP. And it's ugly right now because we're going to clean it up live, but here is our base ammo BP, and we have an on component begin overlap event in here. So essentially, when the ammo collides with an enemy BP, then we check to see if it hit a collision box or a weak point hurt box. So essentially, was it like a body shot or a headshot? We were spawning different emitters at those locations to identify which type of collision it was. Then after that, we were determining the amount of damage that that would actually do by getting the weapon that fired this type of ammo. And we were calling take damage. Now, as soon as we call take damage, we want to spawn this actor. We could do it in the code as well. It doesn't have to be in the blueprint. Doing it in the blueprint here because we've done the take damage call in the blueprint, but you could definitely do it in the code without any issue. Just spawn this actor. It'll work from anywhere as long as you can pass in the appropriate parameters. And so in this example, as soon as we call take damage, I want to spawn actor of base floating text. And to do that, we can search for spawn actor from class. And we can select the same class type, the one we just made, which is base floating text. Now, in here, you have a spawn transform. We don't really care about the rotation or the scale in this case, because we are going to allow that to be determined by the component itself. The location is important because we do need to know the actual spot in the world we want to spawn it, and it should be very close to where the damage was done as well. It doesn't have to be at the exact spot, but for now I'm leaving it there. So you can actually right click on the spawn transform and split the struct pin to separate all of the elements of a transform. And we just need to fill out the location here. Everything else can stay the same. Now for the location, I was using the get actor location where we were spawning the emitter. So basically the location of this ammo. That's it. Again, it's up to you if you actually want to do that or if you want to put it somewhere else. The collision handling override is fine. The damage amount is something we should pass in, and we actually have this right here from our cast the base weapon BP. So when we cast the weapon to get the damage to call take damage, of course we have the damage right there. Now, the damage is technically on a scale of 0 to 1. In this case, we were multiplying our damage by 0.01 to get it within that range. But we actually don't want to do that here. We want to display the standard damage that the user would want to see, or the player would want to see. So I take the damage amount from before the multiplication and pass it into the damage amount. So instead of saying 0.15, it'll say 15 if the player did 15 damage to the enemy. The instigator we don't really need here, although you could use it if you want. And the owner is hidden by this arrow here. So if you click this arrow, you'll get the owner. And we do want to set that because we use it to rotate toward, remember. In this case, I'm using the owner of the weapon as the owner of this floating text, because the owner of the weapon is who shot the weapon, and thus they are the ones that dealt the damage, so they own the floating text. So, just to recap, we have our location, we have our owner of the weapon as the owner here, and the damage amount before the multiplication. Now, because of this, we can actually put this node in here, just like this, and it is a little bit ugly because of its size and because of the other things we have in here. So let me organize this very quickly. And even something like that is perfectly fine. And there we go. So now I'm just going to add some reroute nodes to make these connections a little bit nicer as well. And instead of using the get actor location from all the way back here, I'm just going to use the same node up here. And there we go. So now our spawn actor base floating text is complete. And when you come to the game, you should actually see it here. So I can shoot an opponent and the text will display. And of course, if I shoot them with a different weapon that does different damage, you'll see different values. This is technically just for the body shots right now, the collision box, so we can add the same node to the weak point hurt box, and you can do different things with it, such as changing its color to represent that it was a critical hit. But in this case, just make sure you have the node in here at least, and that will be enough. So I'm going to put it right after take damage. So here are your two cases. You got your collision box up top, and again your weak point hurt box, which is down below. And so in here, we want to pass along get actor location. Then we want to use our damage. It is a little bit different for the damage amount because while we do want to multiply the damage and the weak point multiplier, we don't want to multiply it by that 0.01. So you could actually take your damage and weak point multiplier and multiply them together without that additional 0.01, just like this. And pass that into your damage amount, and that will do the trick. And then lastly is the owner, which of course we can get off the base weapon BP again, so get owner and pass that into the owner. And there we go. We're going to try it out together, but this should work for headshots as well, and it should be a higher value than the body shot. So if I hit my opponent, 45 damage, so that is the correct damage, and it does the floating text as well. And there you go, guys. That is how you can add floating text to your first-person shooter tutorial series. I hope you enjoyed, and if you did, please subscribe. It does more for myself and the channel than anything else you can do. It's completely free. I want to give a huge shout-out to your YouTube membership, Patreon members, and Discord supporters. Thank you guys for everything. You're so kind, and you really keep these series going. So I really, really appreciate you. If you had any issues while following this tutorial, or any of my tutorials, feel free to join the Discord community. Completely free. I'd be happy to get you fixed up and let you keep going with the series. Anyway, guys, like I said, that's all I got. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.